Hi, Integral Man here. Welcome to my chemistry lab. Let me show you around. Alright, so we'll begin with my workbench. So this workbench is where I do all my less dangerous stuff, like pouring liquids together, mixing things, anything that doesn't revolve around heating or dangerous gases or any sort of volatile compounds. Now, here I actually have all my waste containers. For example, here's solvent waste. This is where all the volatile organic compounds go. I have permanganate waste, so anything with MnO4. I have alkaline waste, so anything in a basic pH. I have acidic here, and I have general waste here. So that's so I can isolate all my chemicals when I want to dispose of them, and this is just good for the environment, and it's also to stay safe as well. So over here we have wash bottles, and wash bottles are simply just really cool squeezy things. And so if you squeeze them, water will come out. Or if you squeeze this one, which I will not, there's isopropyl alcohol in here. And there's acetone. So these are the three solvents that I like to use. And of course, we have a paper towel dispenser because paper towels are very important. Alright, so moving to the left, we see my drying racks. Now these drying racks are actually made out of wood with a sort of varnish on it, and it's served me very, very well, and it's actually worked for the past 3 years. Of course, we must not forget safety. I have a lot of these fire extinguishers placed around the lab, just in case something catches on fire, which it has happened before. Alright, so let's take a look at my general storage shelves. Now, although these shelves don't contain any chemicals, they contain a lot of very important equipment. So starting from the top, I have some of my contact lens saline solution containers. And I wear contact lenses, so I go through a lot of these. And I saw these and I thought this would be great for dispensing or just any sort of cheap storage, and it served me very well. Okay, let's move down one level, and here we have some of my syringes. Now, I don't do medicine, but actually syringes are incredibly important in chemistry as well. If you want to transfer fluids and don't want to introduce oxygen into the system, you can use a syringe and a needle to pierce a rubber septum, and then bam, you can transfer whatever pyrophoric, dangerous stuff you want. Okay, so, and of course I have some unused wash bottles, some rags, more for whatever incidents or whatnot. And of course down here we have some used syringes. I really don't care if they're sterile or not, as long as they're not chemically contaminated. And of course we have some of my storage containers. These amber glass bottles are perfect when you're handling light sensitive compounds like peroxides. And of course for cheaper containers I have my eye drops, because these containers are actually really good. And of course I have these wash containers, another one of my things I use for contact lenses. They're very, very good. They're a little bit inconvenient to open, but they're a very stable storage container. And right here I have a lot of Chinese takeout boxes, because these are actually very good storage containers as well. These are made out of polypropylene, and as you will see soon, I store a lot of my dry chemicals in these containers. Now moving over here, we have some of my Bunsen burners. Now most of the time in my chemistry experiments, I don't actually use these. I use a hot plate stirrer, as you will see soon. But if I want to do things like melt glass, cast lead, which I've done before, then these Bunsen burners will do the trick. Alright, so let's move over to this lower level. I have a lot of serological pipettes. These are actually made out of polystyrene. They're very, very useful when you want to pipette up a set amount of fluid. They're basically like a precise pipette, hence the name. I have some of these glass ones as well, although I don't see too much use for them because they're incredibly hard to clean. Of course, I have some general use pipettes. I have some sterile pipettes for more sensitive compounds, and I have some general usage pipettes as well. And now this is just a box of hardware, nothing too important about that. Now here on the lower level, we have my drying section. So these are just absorbent pads. When I'm done washing my equipment, anything that doesn't go on the drying rack, so anything without a hole, I just put these on here and then I let them dry by nature. Alright, so moving to the right of my workbench, we stumble upon two of the equipment that I use just in general senses. I have a vacuum pump here from Harbor Freight. It was really cheap and it's very, very effective. Although I have to be careful when it draws a high vacuum, it does smoke a bit, so I tend to open the window or do whatever sort of ventilation I need to do. And here, of course, I have water dispensers because water is essential to chemistry. And note that I put do not drink because this might be contaminated with other substances and I don't want people to drink it. Alright, so moving over to this side, where you'll see my fume hood. Now this fume hood is something that I made myself because just industrial made fume hoods are too expensive. And so at the heart of the fume hood is actually a bathroom fan. The first time I used a bathroom fan, I actually had it short out when I put too much hydrochloric acid fumes into it, and that was actually pretty bad because now hydrogen chloride was pouring into my lab space, and that wasn't very epic at all. However, now I have a much better pump or fan, and so basically this is connected to a switch, so when I turn it on, you hear the fan going. This will just expel it out into the outdoors. And so this is very useful when I'm working with anything corrosive, anything that produces smoke, or anything I don't want to breathe in by accident. Now, typically industrial fume hoods have these sashes that move up and down, and I try to mimic that using a counterweight system. Now this plexiglass, it's actually a thick piece of plexiglass just in case any explosions happen. It's quite heavy, so I couldn't just use friction alone. Instead, I actually used a counterweight system. This string right here is connected via a system of pulleys to this counterweight. And this counterweight is just a bucket filled with sand and some bolts to make it extra heavy. Now this is almost exactly the weight of this plexiglass plus or minus the force of static friction. So I can move this anywhere I want and this sash will stay put. And this is a super cool feature that I love to use. And of course, if you look in here, I actually have an outlet. And so this outlet here is actually controlled by a switch up here. So in case I have a fire and I'm using my hot plate stirrer, I can easily turn that off and resolve any sort of electrical fire issues. Because I actually use my hot plate stirrer in here a lot. So that's very, very helpful. And of course you'll notice again, safety. I have a big fire extinguisher. I also have a smaller fire extinguisher. Now I've actually never had to use any fire extinguisher except for one, and I'll talk to you about that incident a bit later on. Alright, so moving on, we're going to talk a bit about my equipment. Now this cabinet is just equipment, no chemicals. And of course we start out with the Erlenmeyer flask. Now by my sources this is illegal in Texas, but Texas is just a weird state, so whatever. So I have all sorts of sizes, and so this is very useful when you're seeing the typical chemist stance where you're just kind of swirling liquids around. You don't want to get all the liquid everywhere, so that's why you have this sort of the funnel top. And so these are very, very useful when you want to store liquids, you want to stir liquids. Really just a good all-purpose item, only second to the beaker. And of course I have a sort of a weird Erlenmeyer flask. It has a little bit of a tip coming out of it. And so this is useful when you want to do vacuum filtration. Now what is vacuum filtration? That is when you hook a vacuum pump up to this port right here and you just start sucking the air out. Now this air has nowhere to come in except through the top. And so we're letting the atmosphere push your liquid down through this filter and into this flask. This is very useful when you want to have when you want to filter things that are very fine and typically gunk up very quickly. This is very, very useful. Alright, so moving on to my miscellaneous section. I have a lot of random stuff in here. I have a separatory funnel, very useful when you separate things like oil and water. Of course, you do more specific things like ethyl acetate and say water or anything with density differences, very useful. I have here some tongs. This is a general purpose tong, also crucible tongs. This is a beaker tong. So whenever you want to handle hot glass, this is your friend. Of course, I have the scoopy boys, and so this can scoop up any sort of chemical, dry chemical you want. Very, very useful. They're just basically shaped like a V. All right, and of course I have evaporation dishes. Now these things are just useful when you want to boil something to dryness. You can't do this in a flask because the thermal shock will typically crack it, and that's not really good. But these ceramic things, first of all, they're very, very cheap, so if you do break one, it's no big deal. And secondly, they are designed to withstand more of a heat shock. Of course, I have some more watch glasses. So these are, they're named after, watches because they're actually used to be the sort of top to these glass watches. But now, of course, they're much larger, and they're just used to store samples, or if you want to put them over like a flask to seal it off for a bit, or really anything like that. And I have a burette, and this one's quite large, but when I want to do some analytical stuff, titrations, potentiometric, acid-base, any sort of stuff like that, we're just basically dispensing out liquid, and we're able to measure how much liquid we dispense. That's the big idea of a burette. We have some thermometers. Now I actually don't use these much because I have digital thermometers, but this is useful when I just need the analog and distillation systems or something like that. I have some graduated cylinders. These are polypropylene. Never handled hydrofluoric acid before, but if I do, this is what I'm going to use. And last but not least, I first of all have the mortar and pestle, and I have these funnels. Funnels are just useful as funnels. You know how funnels work. Oh, I almost forgot to show you. I actually have these stirring pellets. Now these pellets themselves are actually coated in Teflon or PTFE. And then the idea is that if you have a magnetic stir, there's going to be a moving magnet underneath the machine. And this will cause a moving magnetic field. And these tablets can be put inside a beaker or Erlenmeyer flask, and this will spin alongside it. And so this is useful as a contact-free way of stirring things. All right. So moving down to our most stereotypical chemist item, and that's the beaker. I have quite a few beakers. They're actually very, very cheap if you buy them off-brand. And so really nothing much to talk about. They're just things to store stuff in. They're elaborate cups, basically. And of course, I have my round bottom flask section. So these are things when you use for distillation. Now this isn't fritted glass, so I don't really use this much. But if you have, this container especially has these fritted glass fittings. Now what you can do is you can actually put other fittings together. Say if I wanted to put like a funnel in it, easy peasy. And this is useful when you want to conduct distillations, or basically like Lego pieces. And this is where you put the stuff you want to distill and you just heat it up. I have all sorts of sizes. This flask has the fritted glass on top, or the ground glass on top. And then I have some of my more miscellaneous items. I have a bucket, so when I want to do oil distillation or water-based distillations. Have some tripods. Basically, they're good when you want to heat stuff up using a Bunsen burner. And so that's basically it for the equipment stand. So on to the chemistry stand.